Every day we transform the basic matter of the planet. How this will change the global climate is not clear. Meteorologist Richard Somerville explores the Earth's climate and our emerging role in its future at Scripps Institution of Oceanography.
Now, research on climate is actually changing much faster than the climate itself. Climate as a study, the field of climatology, used to be very dull. It was compiling statistics and data. And now it's turned into the study of the Earth as a unified system. It's an interdisciplinary subject. It's bringing together people from all different sorts of scientific fields. We're all looking at this great, big, complicated beast from a slightly different perspective.
There's not a whole lot going on. So in that sense, it's good. They're not supposed to be
That's right.
much going on.
So when the monsoon kicks in...
To understand climate patterns, Somerville and his colleagues create mathematical models inside computers.
When we talk about a model in a context like this, we're really talking about a collection of natural laws. The laws that relate temperature and pressure and wind and humidity. They just happen to have a mathematical expression, but you could say them as well in English. They have rules in there like, if the humidity is greater than a certain value, let a certain kind of cloud be said to exist. And if that cloud is there, let it have a certain effect on sunlight. That kind of thing. They just get to be expressed much more compactly in the form of equations.
Models predict how things change by simulating their behavior. A real thunderstorm can't be studied in a laboratory, but by combining data and theories, its dynamics can be explored in a model. A model can predict man-made phenomena as well. This model shows the flow of air pollution across Los Angeles. Climate models link global systems like clouds, winds, and oceans to simulate the Earth itself. By running the clock forward, these models forecast how the climate will change. But more data is needed before they can clearly predict our impact on its future.
We still don't have an honest global picture of the climate except in very recent years. The satellite changes all that. In principle, the satellite looks at the whole Earth equally. Sometimes you have to work hard to see what the satellite is trying to tell you, but you've got the planetary coverage, and that's what's critical about it.
One mystery climate models cannot yet explain is whether clouds warm or cool the Earth. Clouds trap heat beneath themselves, like blankets, but their bright surface also reflects heat away from Earth. Constantly changing, clouds are too elusive to measure from the ground. In 1984, the Earth Radiation Budget satellite was deployed to measure the heating of the Earth by radiation from the sun. This satellite would help solve the cloud mystery.
This is a particularly good view for the story of this,
For 7 years, Somerville's colleague, Virabhadran Ramanathan, has been sifting through satellite data, a volume of numbers that could fill millions of books. By visualizing information, Ramanathan can search through it, using senses and intuitions to find answers.
The combination of very powerful instruments mounted on our satellites, and then our ability to synthesize this information with the help of modern-day computers, is what gives us an unprecedented opportunity to probe the system in such an enormous detail that we can pull out some simple information from that, which is what is the net effect of this collection of cloud systems on the surface of the Earth.
The heating effect of clouds depends on their shape. With his team, Ramanathan explores tropical cloud structures to learn how these vast systems influence global heat. Massive computations finally lead to a simple but profound conclusion. Clouds cool the Earth. The Earth Resource Satellite, ERS-1, is the first of a new breed that will carry our knowledge forward. ERS-1 is a venture shared by the nations of Western Europe and Scandinavia. July 1991, at the launch site for the European Space Agency deep in the rainforest of French Guiana. Here, ERS-1 will be launched to study the role of oceans and ice in the global climate system.
5, 4, 3, 2, 1, top.
ERS-1 and similar satellites herald the beginning of a new international mission in space. A mission to planet Earth. Orbiting platforms will help forecast future climate trends by building better models and help verify present trends through long-term monitoring. Other satellites will help scientists around the world to communicate with one another and will enable them to share data. Larger storage systems and computers must evolve to manage the deluge of new data streaming down from above. Planting the seed of an idea discovered on a mission to the moon, satellites orbiting the Earth may lead to even greater discoveries about this place we call home. The space age brings us a growing knowledge of our interdependence with the world around us. For many, this awareness is a cause for celebration.
Let's have the hedgehog then can we have the snake, then let's have the bush.
At the Cathedral of St. John the Divine in New York City, the blessing of life on St. Francis Day is about to begin. Long ago, St. Francis taught a reverence for life. Today, people of many faiths now gather in his name to celebrate our ties to the earth. James Morton, Dean of the Cathedral, believes our journey into space uncovered a forgotten truth.
People can understand in a very, very telling way that they are one among many, 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 many species. It's a very ancient understanding, but it's one that was eclipsed for a long time. But it came back, most particularly, and that's why I've got my favorite icon of the New World, this. I mean, this is when you're on the moon and you're looking at this little brilliant blue-green ornament. You know, Rusty Schweikert said, you know, with his thumb he could blot it out. Once again, only in the most recent times, people have had the image in their minds and in their hearts. They've turned around with a new image of what the world is. I mean, this is a sacred image. Every piece is needed and it all fits together, and you're aware of this interdependence of one upon the other, upon the other, upon the other, upon the other. They're all there at once. That's what the view from space gave us. That was the gift. That was the religious gift.
Over 30 years, space technology has helped us understand the meaning of the living whole. Traditions and cultures are slowly changed by the dazzling sight of what once could only be imagined. In a dark universe, we find a heavenly body swathed in brilliant clouds and marbled with brown continents, jagged peaks, and blue seas. We discover our origins traced in the patterns of a living realm that circles through the heavens. From afar, we behold the watery cradle where life itself began. Curiosity has taken life to a place it has never been before. We extend our vision to look down on the planet, and with new knowledge, we now look to the future. For the first time, we can ask, what sort of home do we hope this planet will be? To explore this question is a bold step for the human species. But to even ask this question is a giant leap for life on Earth.
Next week at 8 on Space Age, how space exploration has helped bring about the so-called New World Order. While next tonight, memories of the X-Planes.